everyone else, I mean, you should reiterate this, but we're streaming this on Twitch and recording the meeting, and this time with the voice. Oh, shit.
Discord had already told you to be safe. Here you go.
Cool. Okay, there we go.
Volume.
Now I had the stream going on my iPad because I was trying to test earlier with Zion's voice.
Look, all the good 2 minutes does.
Everyone joins
or
in
maybe
2
it's
minutes.
because they know there's 2 minutes overhead. Maybe that's what it is.
That's true.
All right, well, 2 minutes are up, so let's kick it off. Thanks everybody for coming again. This is the third meeting of the semester, so thanks for coming. Adam is once again doing our sixth lecture for today. Some announcements that you may have seen in the announcements channel already. First off, sorry for the troll. If you were aware there was a troll earlier this week, so sorry if you got added for no reason. We fixed it.
That's right.
So that won't be happening again, hopefully, unless an admin goes rogue and that's everybody. Then, expect it. On another note, we converted the whole Discord to a community Discord. That doesn't mean it's open to the community. It just means it has different features now, which took a while to look into, but now it's good. So now you can share the announcements channel if you want to your Discord of choice. It's very nice. Seesaw went good, like the announcement said. And then the announcement of the 2 challenges, which are now out. The first challenge, which is a Easter egg challenge. You can find it on the CTF submission site. The Easter egg challenge is, of course, an Easter egg, so really we're not going to give you any hints, but it shouldn't be too hard to find if you have 2 hands and Google. It's a good one. The second one is, of course, the membership challenge. So if you haven't taken a look at that challenge yet, go ahead and take a look. It's in the original post that we talked about for getting membership. And recall that the membership is kind of your process of hacking into our server and putting your name down there slated for all time, since the post will remain there for as long as ASU Hacking Club exists. So if you haven't yet, go and take a look at the membership challenge. It's a great way to slate yourself as a legendary hacker. If you're still very new to hacking, we haven't covered the topics yet to get that challenge, but you can self-study if you want. I posted some links, and we're also going to try and get some automated challenges out to you guys soon. So you may see it coming soon. I hope you guys enjoy it. And other than that, we don't have anything else. The next CTF will be in 3 weeks, but we will have one miniature CTF coming up for the rest of this month called Flare on CTF, which we will make a channel for if you guys want to discuss the challenge. But as far as 48 hours go, we don't have another one until the beginning of October. All right, take it away, Adam.
Cool. Thanks, Zion. Just to reiterate, for those that just joined, we're streaming live on Twitch right now. You should get everything right here on Discord, but this is so that we've surprisingly, I guess, Zion, you'd probably say we've had a number of people who are interested in the club who aren't at ASU, so this allows kind of us to connect with them. I should have
mentioned that. Yeah, we've been getting a lot of people from outside of ASU who have been wanting to take a look at what goes on inside here. So this is kind of the midway solution. So people outside can get a view in without, fully hacking our Discord, because we don't want to get hacked. Yep.
Cool. All right. Yeah, this is great. So we are going to be jumping off. And so as part of that, right, all of the audio that you guys are saying, like what Zion's saying, everyone in the chat is getting streamed to Discord. Is getting streamed to Twitch. The other thing I just realized is I won't have the Discord chat. So let me put that up on my phone as I'm talking, and we should be good. Cool. All right. So if you recall a few weeks ago, sorry, we had to cancel last week, kind of at the last minute. We had some, important stuff we were taking care of. And so we were just getting started in understanding terminal life. And so we'd just started running some commands. We ran ID command, we ran the man command. And The main goal here is that, so at this point, you should understand how the shell starts to parse our command and turns that into a process. So we talked about the operating system, we talked about the concept of a process, this kind of like interesting notion that nothing that we actually do on the computer we're actually doing. All that we're doing is invoking programs that actually do things on our behalf. And so we're going to continue that forward. So we kind of are starting just at the beginning. Well, the first thing we want to do, we're using some kind of system, is we need a place to store files, including our programs. So the very first thing I want you to expunge and literally delete from your mind is the notion of file extensions. So somebody tell me, what is file extensions? Or what's a common file extension?
It's like .txt or like...
Yeah, so exactly. So examples would be .txt. What are some other ones that you know of?
py or
.xl.
.xl.
.exe. Somebody dropped in the Discord chat. What else? .bin, .pdf, .doc, .docx, elf. Yeah, and when we say file extension, right, what we mean is so the kind of format of file names is you'd have the file name itself, a dot, and then everything after the dot would specify maybe something about the file itself. So the very first thing I want you to get in the habit of is completely removing that information from your mind. The fact that if a file has a specific name with an extension of .text or .bin or .pdf or .exe means absolutely nothing. That's actually used on Windows in order to associate a program with a specific file extension, but that doesn't actually mean anything about the file, the contents of the file itself. You can have a pure text file in an ELF file. You could have a pure text file in something without a file extension. And the key thing to remember and to keep in mind as we're exploring is that files are literally just a sequence of bytes. So there's nothing special about files. Files are literally just sequences of bytes on disk. What they mean and what they do depends essentially on what program you give them to, right? So it could be a PDF, it could be a PNG, it could be a GIF. What we'll actually see later when we start doing some kind of like reverse engineering and trying to understand files is there'll be the convention is there's usually magic bytes in a file that specify what type of file it is. So you can actually go look this up. I'm trying to think of one off the top of my head. Does GIF start with GIF? PNG may start with PMG. I don't remember, but if you look it up, you can see. I think there's something like Java class files start with cafe babe, like CAFEBABE in hex values. And so, but again, none of this really matters because files are just a sequence of bytes. So this is kind of the first step towards becoming like a Linux user, is really understanding this notion that files are literally nothing but a sequence of bytes. Okay. So, how many people here like organizing things? I'll go first. I hate it. I think, well, if I guess I'm not in my office. If you've seen my office, I just have like piles of stuff around that I haven't bothered organizing because it doesn't really matter and it doesn't bother me. But when we're thinking about our files and our file system, we could just have one place to just dump our files. If you, I don't know, think about your room or something. If like your clothes, rather than putting them in different drawers or whatever, if you just all dump them into a pile on the floor, that could probably work, right? But that's actually super annoying to deal with. So we need some way of actually organizing our files and put them into different categories and organize some way to organize them. Like, I don't know, I guess this was true of me in my teenage room. I had no organization. So so Linux has what's called a unified file system. So there's, and the two main concepts here are files and directories. So we'll start at the root of the file system, which is /. An important thing to keep in your mind is this is the root of the file system. So slash is the root. It's the start of the file system. You can think of the directory structure as a tree where the root or the first node of that tree is slash. Any files and directories in there will be children of there, and those directories would have their own children. And so you can kind of think of it in these terms. But we'll start with directories. So basically, directories allow us the ability to organize and nest files and directories in them. So for instance, if we have something that represents the path on the file system /foo/bar, this could mean, okay, so in the root directory slash, there is a directory called foo, and inside there's something called bar. So how do I know in this example that foo is a directory?
It has a trailing slash?
Yes, it has a trailing slash, exactly, because I'm saying that in this path, there must be something, foo must be a directory because there's a slash at the end, and I'm saying that there's something in there, there may be something in there called bar. Exactly. So this is kind of the way as you're manually parsing this, right? You separate everything by slashes, and so this now. Yeah, so, and then /foo/hack/, right? In this case, we're referencing a directory called hack, which is inside foo, which is inside of the root directory, right? And here I know, just like we just talked about, and somebody mentioned in the chat, right? Hack has that slash, that trailing slash on it, which means that hack must be a directory. And this is what we mentioned, right? /foo/bar can be ambiguous. Foo/bar could be a directory or a file. Can it be both? Can /foo/bar be both a directory or a file? And a file? And if no, why not? Lots of people typing. No, files don't have to have file types associated with it. We'll go back one more. File types, file extensions are meaningless. They mean nothing to us. It's a good try, though.
Is a symlink a file?
I think that's something we can ignore for now. I don't think that affects the is it a file or directory. Yeah, we'll get there. Right now we're kind of ignoring the advanced concepts, but I think even there. Yeah, so okay. Lots of good concepts. People are asking about. People are getting too deep into what actually happens in the file system in terms of like symbolic links, hard links, technically on your hard drive itself. Yeah, I think that's Sean. I don't know everyone's handles, but technically on the raw file system itself, a directory is a special type of file with a flag on it that says it's a directory. But conceptually, we can think about as no, in some sense, no, like a file, like a file of something can't be both a file and a folder. So you essentially can think of directories as folders, or the other way to think about that would be folders, right? You have to be able to put things in them. You can't actually use them as files. Now, this gets very complicated. I think Windows, you can have No, that's different file streams. I don't know that you can do that. Anyways, yeah. So you can think of a directory that as containing a bunch of files, 0 to many files, whereas a file itself can't contain any files inside of it, right? It just contains bytes of whatever's there. Cool. Good philosophical discussion. I appreciate that. So foo bar we said is ambiguous because we don't know if in this case if bar is a directory or a file. Is /foo/hack/ ambiguous? Do we know anything about hack? Is it a file or a directory?
It's a directory.
Yeah, it's a directory because of the trailing slash, right? Exactly. Now, it may or may not exist. Right, that's one thing that we don't know. We'd have to actually look at the file system to say, okay, is there a directory in the root directory called foo, and does that have a child directory called hack? Cool. Awesome. All right. I just ripped this from 466 for those who are in 466. These are just kind of some, you'll notice there's a lot of important Linux directories out there. So like we talked about slash, there's /USR, which apparently stands for Unix System Resource. I thought it stood for user, and it's kind of pronounced as user, which is interesting. But so in /user bin, we'll have the executable files for a lot of the programs. Also, there's a /bin, so some programs are specified there. User lib will have libraries. User share has other stuff. etc is the configuration directory generally. And again, these are, I wouldn't necessarily say these are standards. Any program can do things in crazy ways. But they're good conventions. So the really good thing about /etc is if you're trying to understand or you're doing a CTF and you want to know, let's say you've gotten code execution or file read access and you want to learn more about the system and you know it's running Apache, you would look for the Apache configurations in /etc. In that folder, there'll be I think it's usually Apache 2 or whatever. So in /etc, there'll be Apache 2 and then some config. All kinds of configs in there. This is also helpful when you're adminning your own Linux systems, as you know where to look for the specific configuration that you need. var is another actually super useful like admin style thing. /var has /var/log. I think it's log and not logs. Will have a lot of the logs of different processes in your system. So again, if you're Xion messing with what were you running? Was it Nginx that wasn't working with the HTTPS and all those certs and everything? Yeah, so
Nginx with HTTPS.
Exactly. So the very first thing I did when I was messing around with that was A, look at etc Nginx to look at the config that Xion was using, and then B, look at var log Nginx, the access log and the error log to see what logs it was giving us. /home is a directory where inside there is directories for every user. Really, if you think about way back the history of these systems, they were computers were so expensive that you as one person couldn't just use a computer, your own. There's actually where the term, the P in PC comes from, PC personal computer, like a computer just for you. Whereas previous systems were like big computers that were shared systems by many people. So you had to have different user accounts on the system. And so everyone had to have a home. So it's in /home. So usually like inside there will be a user's home directory. So like home Adam D would be the user on the system, Adam D, their directory. /proc is actually a really cool way that the operating system gives you data on different processes. We'll actually see this as we go along here. So you will get that in there in /proc, and then temp has temporary directories. So actually anyone can use /temp. You can create folders in there. You can create files in there, but it is not guaranteed to persist on reboot. So usually on reboot, it will be renewed. Cool. Any questions on these? All right. But now how do we actually start interacting with our file system, right? So we'll start off with the very simple command ls. So ls, which you can remember as list, so that's what the L and the S come from, will list the contents in a directory or show attributes of files. So let's do some of these together. And I highly recommend you at home or watching or whatever, typing these commands. Just try them, right? So like ls/.
Finding stuff, basically. So dynamic shell.
And so ls/ will then so again, and remember, going back to, well, let's take a step back a second and refresh ourselves based on what we talked about last time. What's actually happening here? So when I do ls /, what's happening? What's the shell doing?
It's printing the directory file.
Not quite. The shell itself is not doing that.
It's running ls, the program.
Exactly. Yes, it has to find ls. We'll find out later how exactly that happened. It finds and I can actually use the which program. That's annoying because it's not going to tell me. I think it's bin ls/. Yeah. So I have options in there to add color. But anyways, basically the shell is figuring out, okay, I need to execute the process bin ls, and I'm passing it the parameter /. We can do man ls like we looked at. ls list directory contents. How do I use it? ls space some options, and then the files that I want to list information about the files given here, the current directory by default, sorts entries alphabetically, if none of this or sort is specified. So we're already actually seeing cool stuff here. So again, when I do ls/, right, the shell is executing a process called ls, passing it the argument /, and we actually know it's actually not just passing it the argument /, it's passing it two arguments. Oh no. What is going on in Twitch? Pone College is raiding with a party of 29. Is that a good thing or a bad thing?
Oh no, it's the Connor raid.
Uh-oh. Oh no, they're dropping emojis and stuff. I don't know how to deal with that. Zion, you should log in and troll them.
Got it.
Great. Okay, so when we type in ls/, right? Again, so the arguments that it's actually passing to ls, the first argument is actually ls, the exact thing that we typed in. And then the second argument is / right? And the ls program itself looks at that, figures out what the thing is, and types in / and then we'll execute whatever it needs to do in order to properly do that. Can you guys hear me still?
I can hear you fine.
Okay, my computer crawled to a halt, but whatever. All right, we'll rock and roll. Maybe it's all those emojis happening on Twitch, but anyways, hello people from Pone College, good to see you. Okay, ls/, so, and then what ls has to do is then figure out, okay, how do I look at the root directory? How do I list the files in it? And showing me all the files that exist in there. So we can kind of understand, based on our understanding of the man page, what exactly this ls program is doing. It's listing the files and directories in the root directory. I can do ls/home, and it will show me the users I have here are Adam D, and I guess Tiffany B has an account on my system. Should I be worried about that? Maybe Tiffany has hacked my system. And I can pass arguments to the ls command. So if I go back to the man page, I can see that I can pass a bunch of options here. The other interesting thing I didn't put in the slides that you can is interesting to remember is most options in most like Linux style command line arguments, except two ways of specifying them: a short argument like $(a) or a long argument of $(all). And anyways, there's a ton of actually different arguments here. If you thought just like ls was an incredibly simple program, it is not. It has a lot of cool options. So we can do something like ls-l/etc passwd, And -L is the long format. So if I do man ls and look for -L, I will be able to show you that if we read this whole thing, it would say L means use a long listing format. So if we do ls-L, and we can experiment, of course, because we're interesting hackers who want to find out how things work, we can do ls/edc/password. And so we can see if we just do edc password, it will show us that file. If we did it on a directory, it would show us all of the files in that directory. But when we do -L, it actually gives us more information about the files. And we can even, I'll briefly go over some of these things. We'll go over these in more details. But this is essentially who's the user that owns the file, who's the group that owns the file. And I think this is either, when was it last updated or last changed? One of those things. If somebody knows, please drop in a chat now that we have 2 chats. And /edc password. And then the file. So this was, I think, the file, the data, the last modified of the file. I think that makes sense. Anyways. Then I can do things like ls-a/etc. And if I look up the man page of ls, I'd see -a says do not ignore entries that start with a dot. So this is another convention of kind of like the Linux and everything where by default, when you list the contents of a directory, any file or directory that starts with dot is not displayed. So I think... And the other thing I can show is that if we do --all, that should be the same. So -a/etc. We'll do it on my home directory. So yeah, you can see when I do -a, there's all of these dot file. They call them dot files. So .yarnrc, .comp dump, blah, 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 all that stuff. And I can do --all. It should give me the same thing. Next thing is going to be about combining arguments. So I can do -L-A. So I'm doing and let's compare that. So if I drop the all, I didn't get any of those dot files in the output. It didn't show me anything there. But when I did -A, it shows me like .csh history, all of these, every file in that directory that starts with dot. But typing -L-A is super annoying, right? I don't want to type that every time. So I can actually combine all of my short options, usually for most programs. And again, this is because this is program dependent on how it's actually parsing the arguments that you're passing into it on the command line. But most programs, you can combine the short arguments by specifying them as one. So -LA will be the exact same thing as if I did -AL, right? Because it's saying I want those. And then, yeah, great in the chat. Is that Robert? I actually can't tell anybody's name in there. Anyways, Twitch person. H is different. And if we look for -H, it's human readable with -L and or -S print human readable sizes, which is actually super useful. So yeah, I do this a lot when I'm trying to find big files, because then I can see, aha, apparently I have 0.5 meg of my ZSH history. That's super interesting. So it shows you the size of the files in a human readable format. If you don't use -H, it shows it to you in bytes. So you would have to manually convert in your head the size there in bytes. Cool. So I can do ls-la/, and that would show me a bunch of the files there. Any questions here so far? All right. Cool. Okay, so now we know how to look at things, right? So we... Hello? Okay, sorry, I am getting an echo. Oh no. Where the hell is that coming from? Sorry. Stupid. Thank you, Twitch, for deciding to do that. Okay, back on back to where we were. Okay, cool. So now we can show us things, but of course we want to know where we are, right? So pwd prints out the current working directory of the shell. So if we do pwd, we'll see that I am in /home/AtomD, and we can get around. So we can use the, and actually we'll get into this in a second. We'll use the command cd. So cd to change directory to another directory. So I can do cd slash, and I can do pwd, present working directory will show me slash. I can do cd/temp. pwd will then show me /temp. Cool. Okay. Awesome. We can move around. We can do different things. But what we care about and what we're going to come back to at each of these different phases is understanding what's actually happening here under the covers, right? So remember that a shell is just a process in the operating system, right? My shell, and I can actually quickly go back. I don't know if we'll be able to find this one, but I can, kind of getting ahead of myself, but so I have a bunch of different shells running. They're all a different process, right? All of this /bin zsh. So the operating system, actually what it's doing is it's keeping track of the current working directory of every process on the system and says, okay, for this process, what is the current working directory? And as we mentioned, there are system calls for a user space process to be able to call into the operating system kernel and say, hey, do something for me. So in this case, if a running process wants to change its current working directory, it uses a syscall called chdir. So chdir actually is what the shell is doing to ask the operating system to change the current working directory. And it turns out cd is not a process at all. So if we do which cd, the which command will tell us that cd is a shell built in. And I think if I do man cd, it won't tell me anything. And that's okay. So what's going on here, right? So let's first think, why is shell a built-in command? So built-in means it's not a separate program. It's not executing /bin/cd. It's the shell is when it parses and says, okay, the user's trying to execute a command called cd and giving it arguments. The shell itself actually does something from there. So why is it not a program? So could you write a program that reads its first argument and says, okay, call chdir into this directory, and then exits?
Is it because it's less secure?
Not quite. It's not a security thing. It's a good guess.
Does bash keep track of the current directory so it doesn't have to call any program?
Yeah, so bash isn't keeping track of it. The operating system is actually the one that's keeping track of it. Right? So our shell, bash, actually doesn't know its current working directory. It has a way of figuring that out, and we'll talk about that in a second. The pwd is actually also a built-in.
So bash has permissions to look at its task struct entry?
Yeah, there's a so chdir is a system call to ask the operating system, hey, move me to a different directory. I think it's let's look it up real quick. I think it's man get cwd. Yeah. So there's a bunch of, so get cwd, get working directory, get current directory name. These are all system calls that call into the operating system and say, hey, what's my current working directory? Because the program itself doesn't know. So when you type in like pwd, what the shell is doing, again, so which PWD. So it's a shell built in. So the shell, so bash, or in this case ZSH, says, oh, they typed in PWD. Great. Let me ask the operating system, what's my current working directory, and then print that out for the user. And so that will print out /temp, right? But if CD was a program, so let's say I had a program that called into that, took its first argument. So when bash, so let's break it down a little bit, right? When bash executes or your shell executes another process, that's a completely different process on the in the operating system with its own current working directory. So if that program that we just executed called CD called chdir to change the directory, actually, let me, oh, this will be fun doing this. Yeah, so I'm going to do an S and an H. Okay, this is definitely not working. Do you guys think I want to keep these beautiful ink annotations? Yeah, turn it into an NFT. Good, I like that. Okay. So there's the there's the process shell. You know what? I could do this probably pretty good here. There we go. Okay. So big enough that folks can see it. Okay, so I have my shell. Let's call it bash. I think that's fine for now. Right, so bash is a process on the system. It's running. And the OS has, actually it has a mapping of like bash. And it says something like its ID is 10. And its current working directory is, I was in home /AdamD. Great. All right, so all that information is contained in the operating system. And because I like operating systems to be kind of below conceptually user space, so I have my user space. Do you think I'll get an award for these amazing ASCII art diagrams that I'm making? The answer is yes, in case you were wondering. Okay. So in user space, I have my bash process that's running, right? And bash is running, and of course I don't have enough lines of text. So when the user types in pwd, bash makes a get current working directory syscall to the operating system that says aha and returns the string home AdamD and says your current directory is home AdamD. When the user types in cd to change something to somewhere, then the bash has to ask the operating system to change the current working directory. Now, if bash were to execute, if the user types in, executes some program like bin cd / let's just say that /etc is more clear. Okay, that would execute a new program called cd. This process, which now becomes a process in the operating system, the ID would be, let's say 11. It doesn't really matter what it is. The current working directory would be by default home AdamD. And now, when we say change directory to /etc, for the operating system, which entry does the operating system change here? Which is the process that called this change directory system call? no, Connor, you ruined my Zoom. There we go. I fixed it, don't worry. Okay, when the CD program says to the operating system, hey, I want to change directory to /etc, the operating system gets that, and what's it going to do? How is this diagram going to change?
Is it gonna change the current working directory or
Yes, of what?
bash?
Not of bash. And why not?
Oh, because bash is the program running and
Yeah,
the
the
other thing
CD
is
program, this fake CD program that we have, is the one that is calling the system call. So the operating system sees this and says, oh, you're the CD program. You're ID 10. Great. I'm going to update your current working directory to /etc, just like you said. And then this program goes away. This entry goes away. And now bash's current working directory is the whatever it was beforehand, right? So this is kind of why the change directory program cannot be a program. It's actually a built-in of the shell, because the shell itself needs to say that. So as a test, we have our first flag moment. So okay,
Wait, so it's not global enough?
say it again.
So it's because of like global stuff that's not global enough.
Exactly. Every process has a current working directory. Every process on the system, which means your shell has a current working directory. Every program that you ask to execute, like when we type in ls, that ls process that gets created has its own current working directory. And so each process, when it says, hey, change my directory, it only affects that process. It doesn't affect any other process. Yeah, so you can think of it as global versus local. There's not a global current working directory. Each process has its own local current working directory. And so this would be the answer to the first CTF challenge, back to basics nav 1. So the question is, when you type in cd space /foo/bar, this will result in the shell issuing what system call? And the answer is in the format of, so replace, including the angle brackets, the syscall, and replace the argument there. And that should be the flag. Let's see how y'all do. Also, smart quotes are evil. Oh, correct. I just got it. Sweet. 6 people. Keep doing it. It's also an iOS setting, Connor. I actually should probably just disable smart quotes, because every time on this slide, when I typed in a quote, it would try to do a smart quote, and then I think you do Control Z and it will put it back. And then the minute you type another character, it'll do a smart quote, but then the other direction, the wrong direction. It's horrible. Then you do Control Z again and it undoes that and takes it back to a dumb quote. Eight solves. Good job.
Wait, also, where is this flag, the website for it?
It is. Can you drop it in the meeting chat, Zion or somebody?
Yeah, it's already been posted in the meeting chat.
There you go.
It's the link. Like 2 messages above the last message.
Thank you. Sorry.
Mm-hmm.
No problem.
Ten solves. This is great. But you know, what'd be cool is having a graph that came in on the Twitch stream on the stream and showed the solve progress. Yeah, I know technically I could, Connor, but it's actually doing it. Is that something that you can do? Oh, a web overlay? You can do a website and then link up the JavaScript to there. That's pretty cool. Somebody should make a CTFD plugin that does that. Also, the latency in this Twitch chat is insane. Why do people put up with this? What's the point of having like real-time chats about something that happened 5 seconds ago? It would drive me crazy if I did this more often. How is it more fun? All right, I don't understand these Zoomers. All right, how are we doing on them solves? All right, we'll give it a few more minutes. If you have any questions, feel free to ask in chat or in voice. We're here to get better together.
Wait, so we're supposed to only replace the system call and the word argument?
Including the angle brackets. Yeah, so replace basically whatever system call it's going to call, everything including those brackets. Replace that with the system call, and then the argument that it's going to pass, replace the brackets, like those, the whole thing there. Does that make sense?
Yeah.
Sweet. 14 solves. Hey, that's great. I guess you could also do crazy things like put an overlay of the Discord chat also on some side here.
I'm looking for something that could sync the two, that could sync the messages that come in here to Twitch and vice versa. But
that'd be pretty
yeah,
cool.
that might be an easy solution.
Yeah, you could just put it up on the, what side is that? I actually don't know my left or my right in the stream.
It's on your right.
Well, this is my right, man. So it'd be this way, my left.
Oh, it's on my right.
Yeah, exactly. That's what I'm saying. It's weird.
Right.
I understand my own left from right down. It's the question is which is which.
Stage right. Stage right. There you go.
So I'm looking at some of the incorrect solutions.
Mm-hmm.
Your solution will not have the angle brackets in it, your final solution. So some of you are still like including it in your substitution. Just know that that gets completely replaced. So no angle brackets are in the final.
Yeah, this is just kind of a
solution.
convention that shows up in a lot of places that basically says, hey, replace everything here, including the angle brackets, with this syscall. And the angle brackets tell you, hey, I'm the thing you should be replacing. I think I use that in a lot of things. Like username / password, or anyways, all kinds of stuff. Yeah, good job, counter. So do y'all come up with your like hacker, are your hacker handles also your gamer tags or whatever? Is this why you all have some? Oh yeah, 17. All right, we got 17 solves. That's pretty good. You can come back to it. It'll stay up. The slides will remain, and the recording of the video will remain, so feel free. All right, cool. Now, so actually, we were just talking about that. So if we want to inspect actually the working directory, so pwd will show us the shell's working directory, right? So the pwd built-in of the shell will say, hey, operating system, what's my current working directory? Okay, great. Here it is. But we can actually use the special /proc directory structure to view the current working directory of any process. So let's actually go check this out real quick. So I can do, if I do ls-la proc, ls proc, because there's a lot of things in there. So we can see there's actually tons of things in here. So the proc file system actually enables a way for your system for a program to actually learn something using the file system about the different processes that are running on your system. So each of these numbers here is a directory that represents that specific file system's process ID. So like in our little example here in my beautiful ASCII art, right, we had the example of bash having an ID of 10. And it's actually not that crazy. Like there actually is a process here of ID 10. I have no idea what it is, but let's... So, and inside that directory, so there's actually a lot of, yeah, so it's not my directory. This is all actually a root process. So let's get a process that's owned by me. Here's some ZSH thing /proc/. Now, if you try this on your own system, this won't actually work, right? Why? Because you don't have the same process ID, right? So so yeah, in /proc 31945, There's so much stuff in here. But the thing we're interested in is actually CWD. So there's actually something in there, /proc/10/CWD. And if nope, not 10. I wanted this guy, 31945. And the cool thing is this actually will be now we haven't got into this yet. This is more of an advanced file system topic that we'll talk about later. But what this is this arrow, and the fact that it's blue means that it's a symbolic link. So essentially this actually points to the current directory that is this process's current working directory. So, actually that's funny. You can, for those that, if you know what this is, but this process's current working directory of this shell that I have running is in home adamd temp chess eval ta3 eval binary only pitsmore challenge bin. So so it's interesting. So I can see other processes on the system, their current working directory. And if we go back here, now there's a very special thing called proc self. So proc self is itself a symbolic link to the directory in proc of whoever is accessing it. So why is this value changing? Right? It's 24201, 24243, 24283, 24284, and it's roughly increasing in kind of roughly numerical order. Right? So what is this? Is it the shell's ID? No, the shell's ID isn't changing. Our shell is continuously running. It will always have the same process ID until it's died, until it dies or is killed. What this is doing /proc self is actually showing us ls. So the ls process that gets created. Remember, the shell bash will ask the operating system, hey, please execute this program /bin/ls. That execution will create a new process that's running. And that shows up here when we list that. So we can actually do process self current working directory, and that will show us, hey, the ls process's current working directory is /temp. So why is this ls program's current working directory temp? Can anybody tell me why, or have a theory of why?
Because whenever a program runs, it has to make itself like a local storage space.
Almost, very close. So when a program runs, it needs a current working directory, right? It needs a place that it is executing. It could be the default for a new process or a new program could be /, but that's kind of annoying because then a process would just start at the root and maybe try doing weird stuff. So the reason why this happens is actually because my ZSH or my shell's current working directory. So if I do pwd, I would see my shell's current working directory is /temp and ls's current working directory is /temp. This is because when the shell asks the operating system to execute ls, it actually will inherit what's called the parent. So the parent process. So shell is the parent, the ls program is the child, and the child will inherit the parent's current working directory. Cool. So yeah, that's why. So a child will inherit the current working directory of its parent, but of course it can be separate, as we saw, because the child can then change directory and do whatever it wants. Cool. Okay. So far we've been doing a lot of typing. Does anybody feel that same way? I feel that way. We've been typing out the full path to every file and every directory every time we wanted to access it, right? We said ls/temp, ls/etc password, ls/adamd home adamd, right? But it's super annoying, right? We can cd, and we can do this. We can do cd etc. I can do pwd. It would tell me etc. And I could do ls-la/etc passwd, but or I could not type it correctly. I'm going to go ahead and chalk that up to the fact that you can't see it right now, but basically all my cores are being pegged on this machine to bring this streaming to you, the people. So we could do that, but that's really annoying. Like my current working directory is already in /etc. So why do I need to specify that I want to list out the file /etc/password? There must be a better way. So this is one of actually, I don't know if you've ever heard this, but a shockingly good trait of programmers is laziness. Is anybody else out there happy that their laziness is a good thing? And if so, why? Why is being lazy good? So it doesn't mean just playing video games all day, or I don't know, watching Twitch streams or something, or watching other people play video games. Yeah, you actually need to be a special kind of lazy, right? Yeah, so it's about, you want to be efficient, right? It actually goes back to what we talked about the first time, right? You want to be efficient. You want to automate things. You want to say, man, I'm already in the etc directory. Why do I have to specify /etc password? I'm doing this really simple task over and over again. Why do I have to do this? This actually came up. Yeah, great job on Twitch. Yeah, so lazy people find creative solutions, right? So like, yeah, there's definitely a trade-off, right, where you can spend way too much time trying to automate something that really doesn't need to be automated. What we'll actually be getting to in this thing is using the editors correctly, using the shell correctly to do things efficiently and quickly without spending so much time. But anyways, yeah, it can be good to be lazy in certain ways. So there must be a better way, and you are correct. There is a better way. So there's a concept of relative versus absolute paths, where something like /etc/password, does this ever mean a different file, right? No, it's the root directory and then a folder inside there called etc, and then a file in there called passwd. So it's an absolute path that specifies the path from the root directory. And so it's essentially unambiguous in the sense that we mean exactly that file, right? Or file or directory, because as we said, we don't actually know if passwd is a file or a directory. But in this case, we can assume it's a file because we know it exists. We've been looking at it many times. Okay, so an absolute path always starts with a slash. Now, a relative path like passwd means look for passwd inside the current working directory. So essentially what happens is it's just string concatenation. So it essentially does current working directory, whatever your current working directory is, adds a slash at the end, and then looks for a file called password. So will this always specify the exact same file? Yeah, no. Why? When will it reference a different file? Ooh, Cheeto Bambito on the Bandito on the Twitch. Thank you for participating. Yeah, so when my current working directory changes, then the file that this is referencing will also change. So if I do something like cd/etc, now my current working directory is /etc, then I can do ls-la passwd because I'm looking for that file inside the current working directory versus ls-la/etc password. So like, so I can do /etc, I can do ls-la passwd. There we go. I can see that. I can also do ls-la/etc passwd. Now if I go cd/temp and I do ls-la passwd, what's it going to say? There's actually a tip for you. This is a not a tip about this, but a general tip. Whenever I'm running these commands or things, I always like to think about what do I expect the output of this command to be. So here I'm in a temp directory. I'm going to do ls-la passwd. What do I expect it to be? So it should say something like file not found. Thank you, Discord. So it'll say file not found. So it says ls cannot access password, no such file or directory, right? And that is what I expected to happen. If what happened is not what I expected to happen, then I should be like, why did that happen? Let me update my model of what's going on so that I can better understand what's going on. So now if I did cd etc, so just like we said, right? ls-la etc passwd. Will this ever say it can't access /etc passwd? Yeah, thanks, Cheeto Bandito. It won't. It's an absolute path unless, like people are mentioning in the Discord, if I deleted it, right? If this file doesn't exist, but it would be this exact file, right? Every time, no matter what my current working directory is, the absolute path will always reference that exact same file. Okay, cool. Sweet. So you made it this far? Have a flag. I'll give you a few minutes to put this in. This is the, what's it called, Zion? Can you chime in, please?
It's the, what is it? Today's the 15/09/2021. It's the participation challenge. I'll also post a direct link to the challenge.
The text says 14. Is today the 14th?
Oh, it's the 14th. Oops.
Today's the 15th, though.
Oh no.
Oh, no.
Hint, hint, the hash is wrong.
Is it?
I mean, this flag will submit, but things are fun now.
Stop talking.
Yeah.
Could you also put that link in the Twitch stream, Zion? You know, I'm all about them socials.
Somehow Redgate beat me to both of them.
Man, thanks, Redgate.
Wow.
You're the new Zion, apparently.
Sheesh.
Can we make an animated, like, little hacking club emoji for Twitch?
We'll have to get that. I'm not sure what will animate, but yes. The 90s, it had animations, so I see this as canon.
They did have GIFs. Did you know that was the first way that they did, like, asynchronous style websites? So
No.
I saw a proof of concept a long time ago. It was a chat app done all in GIF. So basically what it would do is, because with HTTP, you can make an HTTP request and the response for a GIF would stream in, right? So the server's response would keep that open. It would send you one frame every time it wanted to update the screen. So you'd have a little GIF on your screen, and every frame you got in, it would update it and, like, alter the stream with whatever, like, new message that came in, and then it would push out a whole, like, new GIF frame to your browser that would take that and render it.
That's amazing.
Yeah, and this is all because the web was so slow that you had to have file formats like a GIF that you could stream, because, like, you would just show a frame whenever you had it and it was ready. And so, yeah, this is how they used to do that stuff, which is crazy.
This has got to be a CTF challenge.
Yeah, that would be really fun. I think you can still do it. If you Google around, I think you can find it. But yeah, I think that's a legit thing. All right, we'll give it a few more minutes. You can always come back to this video. So I'm going to redact this flag in the slides that we post. But and actually, let's do this now. So goodbye flag. You were a good flag. And we'll redact it now. You can come back to this video. When we post it, it will be in the video, but not in the slides. To show how a true elite hacker you are. All right, good job, those of you that got it, all 19 of you. So there are two special directories that we saw, actually. So when we did ls-la/etc, and we went to the top, we saw the special, we saw a bunch of we saw some dot files, so files that start with dot. And then we had these directories dot and dot dot. And we think, is this something special in etc? Let's look at slash. So we look at slash and we see we have this file dot and dot dot. So these are actually two special directories. Dot dot means references the parent directory. So when would you want to, in what type of path would you want to reference a parent directory? Or when would it be useful, let's say? So let's think about it like this. Do you need to know the parent's path when you're referencing an absolute path? Sorry, if you're talking on Discord, I was switched over. No. Okay. Yeah. Thank you. Right. Because an absolute path, you know every single directory. So you don't really care whose parent is what. You're specifying the exact path to the file. But if you're specifying a relative path, then you would want the ... to go to reference, maybe rather than saying, hey, I want to open up a file in the current directory, hey, I want to open up a file in the parent directory. And so ... because you may not actually know where you are in your current working directory, you may not necessarily know the parent's name, but you know you want a file from the parent directory. Cool. So we can do this with, let's do this. Yeah, so we can do cd/etc. And if I do ls/la ... temp, no, ... /tmp. Now, what absolute path is going to be, are we going to list the contents of here? Yeah, /tmp. Great. So we go into the parent directory. Who's the parent directory of etc? /. Exactly. And then we go into temp. Perfect. So the root directory, and then we go into temp, which is inside of root. Awesome. And so essentially what's happening here is it's using the current working directory. It's again just a relative path, and it's done just like all the others. So it's the current working directory / ... tmp. Cool. And dot references the current directory in the path. So this is needed in some weird cases where you need to specify, hey, I need something like from relative to this current directory, and it helps to be extra specific. We'll actually see. I'm sure you've actually done this many, many times when executing things from the command line sometimes, especially when you're compiling it yourself. And we'll actually get into exactly why that's needed later. So we can do this. We can do cd/etc, which I'm already there. And I can do /etc. etc phone home. Okay, ls-la ./passwd. Right, so that's exactly the same thing as if I did etc dot etc /pass ./passwd. Cool. So in each case, it knows exactly what that file is. Awesome. All right. Cool. So now you have a test. Pass this test, you get a flag. Everyone loves flags. So what is the final file referenced in this path? So specifically what we're talking about is the absolute path and without dots or dots. So essentially resolve all those to the full absolute path. Assume that your current working directory is /etc/foo. And here's your path. The answer is the flag for back to basics nav 2. We'll put you know what'd be cool is like a Jeopardy timer countdown thing along with the score increase. You know, Connor, I don't know if you're out there, but you should really get on that. Oh, no, wait. Sorry, I forgot. The only way to get Connor to do something is to tell him it's impossible to do, and then he'll do it.
You gotta nerd snipe him. It's the only way.
Exactly. Ah, he did get it. He is out there. There is a Connor liveness sighting. Was that the real Professor Zardis? I don't see you on the scoreboard, Professor Zardis, so you must be a big noob. Which is good. We all start as noobs, so that's how we get better. No, is that actually Jan? Is his handle Professor_Zardis?
Yeah, looks like it is.
Wait, how come it's not Zardis?
Nope.
Capital Z Zardis.
It probably was taken already.
Wow. Lame Zardis.
I know. Are you going to be a zealous and ardent person at the same time? No.
It's true. Could have been at least Dr. Zardis. I feel like that's pretty good. That can't be why, man. They have a forget password setting. He's saying in chat that it's because I forgot the password to capital Z Zardis. Anybody getting it? Anybody solving it? I hope I did this right.
No solve on the challenge yet.
You mean you're not solving it, Zion? It's bad news. All right, fine. I'll do it on my phone while I'm waiting for y'all.
Quick. Somebody make
Oh,
a
did it.
temporary file. Oh, wow.
Did it.
Okay.
On the phone, too. It's almost like I did this last night when I created this problem.
I guess the real pro move is to just copy his file system, guys. There you go.
Yeah, you know. But now I should double check the... Wait, what? But Jan, what if you get famous as Professor_Zardis and nobody actually knows you as Zardis and they expect you to be Professor Zardis everywhere? Ah, 2 solves. Yes. Icon, best on. That would be a bad news. Oh, I can require. Oh, that's cool. All right. Goodbye. Say hi to baby Jan for me. Actually, say hi to baby Brooke for me. Some of you are very close. You're getting it. Just can approach these like all kinds of CTF problems. Zion doesn't happen all the time where you think you've done everything correctly. You get to the end, you don't get the flag.
Here we go. CTF close.
And so then you have to go back, revisit your assumptions, see what mistakes you made, and start there.
I think the longest streak I had is being CTF close for 12 hours. Just 12 hours of saying, no, I'll get it. Just like 5 minutes. Give me 5 minutes for 12 hours straight.
There you go. That's, yeah, that's how it goes, and people are close, which is good. Just gotta work it from the beginning. Sometimes actually, even with CTF challenges, it actually helps to like actually start from the beginning. Okay, let's just walk through this again one more time. Or the other thing that's super helpful in CTF challenges is revisiting your assumptions and saying like, okay, what assumptions am I making here? Did I actually validate them? Are they true? How can I quickly, create some sort of validation test to see if my assumption is correct or not? All right, how y'all doing? We're still on 6. What do you think? Is it time for a hint? 8 solves. Good stuff. Devil's Canyon and VVS. Oh, shoot. I forgot about the Discord. I keep looking at the solves. Had to bust out the pen and paper because you got frustrated. Yeah, it's sneaky. Yeah, it is sneaky. I mean, it looks like it should be easy, but it's actually not. You really have to like go through it and just concatenate the strings and then start deleting things when you delete the dots and just take it step by step. I think I double checked this in Python too, but I can't remember if I did or not. I think I used pathlib. Yeah, and that's actually another good thing. Good point in the chat is honestly, I mean, I do a lot of my, I usually like to have like pen and paper or an iPad or something to like write on when I'm doing like CTF challenges to take notes on or to do, I don't know, types of calculations or keep track of where I am. Oh, great. 2 more solves got in. Good job. El Tomas, good job. All right, quick hint. Make sure this very last one, you notice that it is .foo and not /./foo, right? So .foo is then part of that file's or directory's name. So just make sure to keep that in mind. I suppose I could actually base these hints on what's actually happening, but. And then make sure you're submitting the full path. So the full path includes the slash. $11 solves. Good job, Squib. You're not a squib, you're a wizard. Oh, 13 solves. Asahe 5 and now Highway. Nawa. Good. All right. Is that Sandy? Is that how you pronounce that handle? 54 NDY. Cool. All right. Let's keep going. This will be up. The slides will be up. The meeting notes will be up and everything. So you can continue working on this. Just remember, take it step by step. So like what I do when doing something like this is I would kind of start with some things that I know for certain, like that Emacs is, there you go. So if I had something like foo ... /bar, right? I could actually just take this and say this ... slash is inside foo and going to go out, which means I can delete foo. And so that would reference the file /bar. If I have bar /foo /... Adam D. One thing I could do is just get rid of this dot because it means the current directory, so it doesn't actually give us more information. This ... will get rid of this foo, and I'll have /bar Adam D. So you can use that. I'm sure you'll be able to get that flag. All right. Other helpful commands as we try to live our best terminal life. Cat. So cats, I'm allergic to them, but I like them on the command line. It actually is very strangely named. The goal is you give it 2 different file names and it will concatenate them together and print that to standard output. If you give it 1 file name, it'll just print that 1 file name. So most people use this just to show you the contents of the file. And remember, the content is king. It's the only thing that matters in a file. So we can do things like cat /etc passwd. And that's how we can actually then see the content of the etc password file. We can also view contents in a different way. So less shows the content of a file with paging support. So you can navigate up and down, you can search, you can do all kinds of cool stuff. /etc password. So some tips when you're in less, you can do the space bar to move down a page. I think, G will get you to the top, Shift G, so capital G will take you to the end. There's a whole bunch of other, I think the default here is basically like Vim key bindings, if that's something you're into. You can hit quit. Somebody just asked me to explain a joke because, of course, when you explain jokes, it makes it funny. So less, there's, the famous saying of less is more. So less, literally the name less comes because it's in opposition to this program called more. I don't even know if more ships with anything. Let's see. Oh, yeah. So more is a similar-ish program. Oh, but you can see like when I got to the end, it just quit instead of going there so I could scroll up and down. So like less is more, but it has more features, which is funny. Yeah, thank you. I'm glad you appreciated that joke explanation. See, less is a program similar to more, but it has many more features. All right. But yeah, it's super useful. I use it a lot. I use a combination of the two. If I know it's going to be a big file, I'll probably use less. If it's something that I think is going to be small, I'll usually use cat. grep is a super useful command to find patterns in a file. So we'll get into, and you'll go throughout your CS career, you'll understand exactly what these patterns are, what the theory is behind them. Any of you who've taken 355 and 340, you can appreciate the nuance and complexities in regular expressions. For now, we'll just think of it as like string matching, even though it is much more powerful. So I can do something like grep. So the pattern I'm looking for is root in /etc passwd. And this will show me, rather than when I catted out that file, it showed me all the contents of the file. What this is doing, and let's look at the man page for grep. So all of these are print lines matching a pattern. So grep searches for that pattern. So again, the way we read this, we first call grep, we pass it any options that we may have. We then give it a pattern and then any number of files, which is what we did. So we did grep, we didn't give it any options. In this case, how do we separate options from the pattern and the file? How do we know which ones are options and which ones aren't? So let's say I wanted to give it this -i option, the ignore case. Yeah, good. So thank you, Discord. Yeah, so options start with dashes. That's actually how it knows. So I can do different options. I actually can do the same one twice, although that does nothing. I don't know what. Let's do V is one. So V actually is a really cool one. Lowercase v, because obviously this uppercase V is version. V is to invert the match. So select non-matching lines. So this gives me the output of every line except for those that contain root. Anyways, all kinds of cool stuff. And so I can use this for look for things. Looking for things in files is incredibly important, right? I may have a bunch of files. I want to see which are the ones that just have the things that I'm interested in. Incredibly useful tool that comes in a lot. Other commands, this comes in actually more in terms of when I'm doing like data analysis, where I like want to compute something. So WC, which I believe stands for word count, will print out not just the word count, but will print out the new lines. So the number of lines in a file, the number of words in a file, and the number of bytes in the file. So if we do WC /etc passwd, we'd see there's 37 lines, 5 words, and 2016 bytes in that file. So this can be useful to understand those kinds of things. Like in etc password, this actually is, each line in here is a user account on my system. So I could actually use this, and I'm getting information about my system now. It's summarizing that and saying, okay, there's 37 users in your system, right? That's kind of interesting to see. Yeah, 50 words. So it's lines, words, and then bytes. And you can specify, if we look at the man page of WC, we can only print out the things that we're interested in. So -L prints the new lines, like how many lines are in the file. -W will print just the word count, and -C or -- bytes would print the bytes. So we can do WC -L etc PASSWD. So that tells me that there's 37 there. And cat just outputs the file. So all we need to do with cat is give it some options, which there are some, and then number. What's number? Oh, that's cool. See, I didn't even know it had this option. So this is cool. So it will print out not only the content of the file, but put line numbers next to it, right? So this is actually could be kind of useful to understand, okay, what's happening on which line of the program. Cool. Any other questions of those examples? Somebody's typing. Is there? I don't think there's a dog command. Yep, sorry. Only cats. Oh, in case I definitely did say this, right? It comes from concatenate. Like that's where the cat part comes in. Cool. Okay. So, how do you list the files in a directory? What command do we use for that? What program do we use for that? ls. Great. How do we search for patterns in a file? grep. Awesome. Now, let's say you have a directory with 1,000 files and you want to see, is there a file that's called Adam or Jan or Foo or Bar? So how do we show all files that match a pattern? Well, maybe there's an option to ls, right? Maybe ls has an option, just like we saw cat has an option apparently to put the line numbers next to it, which is nice. So I could read this whole thing. I could see, and if I go up here, so I have a way to hide things. Do not list, so I can specify a pattern and hide, so I can hide things that I output. Okay, but that's maybe not what I'm interested in. I can ignore things, so I can do not list entries that match this pattern. So I can ignore things, but I can't just use a pattern to search for only that thing, right? There's actually no functionality in here. So then we're like, shit, what do? Do we write a program called ls-grep? Maybe there's a program called that, right? It would make sense, like, you know, a combination of ls and grep that will look for something and do that. We can do man ls-grep. ls-grep doesn't exist. grep ls, maybe I misspelled it. The fundamental answer is no, I didn't misspell it. I didn't do anything there. This is actually at the root of what we're going to get to is a fundamental like Unix philosophy of combining simple programs together to do complex things. So the goal here is we're going to build up and use these basic building blocks. Is the ls command complicated? No. Is the grep command complicated? No. But we'll show that we can actually use them together in ways that probably their designers didn't necessarily intend to do things that are super cool. So it turns out we don't need to write ls-grep. We don't need to write functionality inside ls to search for patterns, because guess what? That already exists in grep. Again, this comes to laziness, right? You're a system designer. Do you want to write another freaking program called ls-grep? No, you're lazy. Do you want to add functionality to ls that implements searching functionality like grep? No, that already exists in grep, right? You're lazy. You don't want to repeat yourself. And so the shell actually gives us this amazing functionality to combine programs together. So using the pipe character, so this is the bar, also called the pipe character, we can basically tell the shell, hey, feed the output of the program on the left of the pipe as the input to the program on the other pipe. So that's why you can think of it like a pipe. Like it literally is creating a connection between the programs. So now, so every time we used to type, like ls-la, what was the example here? I think it was slash. Yeah. ls-la/, right? So I can list all of the directories here, but let's say I'm only interested in the temp directory. I only want to look for that, right? Maybe there's 1,000 lines here. I can use the pipe character and say, pass the output of ls-la/, literally this exact thing I'm looking at, pass it as the standard input of the grep command. And now grep will, and grep actually, the super cool thing about this, grep actually doesn't realize that it's searching through input from another program and not necessarily from a file. So it just goes through, just like it was going through a file, goes through all of this and says, aha, this line matches temp. I'm going to show this to the user. The answer is yes, you can nest pipes. So you can do, and this would tell me, so this tells me, hey, in the root directory, how many things have the word temp in them? You have to kind of be careful of what you're actually measuring, because it could be, there could be a user called temp, TMP, that this would match on. But this is telling me when I do the line count, I can see that, aha, I only have one entry. There's only one folder called temp. And I could do things like how many things have the letter T in them? Well, that's all of them. How many have var? One. How many have any of these things? So, so this allows us to create and do really complex things. So yeah, we could kind of get silly with it. We could do like ls-la/ pipe that to WC, and that would tell us roughly how many files are in there, and we could pass that to WC, right? And what's this last one showing us? So what's this output here? What does it mean that there's only one line, 3 words, and 24 bytes? Where's that from?
The word count of the already filtered thing.
Exactly. This is the output of this WC, right? And we can see there's only one line. There's 3 words, 37, 336, and 4148, and that's 24 bytes. And we could even run this again. I wonder if we'd reach like a... Yeah, okay. So we reach a point where it's exactly the same. That's kind of funny. But we're still executing. Each of these is a different process that's executing on the system. It's super cool. We can also combine things in different ways. So we could, let's say we run some command and we want to store the output of that command as a file because we want to analyze it later, because we want to run some analysis on it. So we can do that with the file redirection. And again, the important thing to remember is these are all things that your shell is doing. So pipe is the shell. The shell is parsing that input, just like before when it does ls-la/, right? Your shell is parsing that and say, aha, I need to execute the program ls, and I need to pass it as the first argument ls, the second argument the string -la, and the third argument as slash. Well, your shell does all kinds of stuff and says, I see a pipe. That means I first need to execute ls-la/, and then set its output as the input to another program called just WC that I'm going to execute. So it executes 2 processes and links up their inputs and outputs. It's super freaking cool. And we can do file redirection. So we can do, so here we can do ls into /tmp/ls_output. And what this will do, we'll see. Now, why didn't this command output anything? Everything I've ever done has always outputted. Every time I ran ls, it outputted something. How come this didn't output anything?
Because it was saved to the file.
Exactly, because of this redirection. And again, it's not anything special. ls did nothing differently. The only thing that's special is what the shell did is the shell took the output of ls and redirected this and created this file. So how do we look at the file? What program do we use to look at the contents of a file?
Cat or less.
Yeah, cat. We know this is a small one, so we'll just do that. And boom, we can see this is the output of ls. It was stored to a file rather than being being shown to us as standard output. Yeah. Hello, then 3worder. Nice to see you. Thanks for participating. Cool. And we can even combine what we were doing. So we can do ls-la / grep tmp, and then redirect that output to a file called temp ls_out. Hit enter. Again, it doesn't output anything. So what is it doing? First running ls-la/, and because of the pipe taking the output of that, putting it at the input of temp grep temp, and then taking the output there and turning it into the file /cat/tmp ls_out, and boom, we get the content there. So by default, the output of commands go to, essentially when you're running them like this, they go to your terminal. So this actually the shell knows to print this to the terminal and output it to you, essentially. Cool. And the super cool thing is there's, again, nothing special. ls did nothing special. grep did nothing special. The shell simply makes the standard output of the grep temp command be the file /tmp /ls_out. And essentially you can think of it as capturing it, and any output there goes to this file. So this is a super cool way of, like, when you're running a process that's going to run for a long time and output a lot of log messages, you can run it, and we'll see later how to run it in the background, but you can run it and then you can redirect it to /temp to a file so you can view the contents of the process as it's running, and essentially as like a poor man's logging functionality. And we can also go the other way. So you may have guessed, right? We have an error. You can think of like this this angle bracket as what is this, a greater than symbol, right? So you can think of the output of that command is kind of getting, visually going into that file. And we can go the other way. We can say, let's redirect the input. So we can use the content of a file as input to the program. So we can do things like before we've been doing, so when we did when we did ls-la/ and passed it to grep, let's say sh, right? So grep sh on its own is reading from its input and looking for things that match that and output it. So if nothing matches, it doesn't output anything. And so we can do grep sh etc passwd. This is exactly the same as if we did grep sh /etc passwd. Right? Because in this case, we're telling grep, hey, read from this file, because grep has the functionality to read and search for a pattern in a file. If we don't pass in a file, it looks for it in its standard input. So when we do grep sh and then use file redirection of the input, we're telling the shell, open up the file etc password, and then have grep, when it's reading for input, read from there. And so we can do all kinds of crazy stuff. We can so this command, let's see, clear cat /etc passwd, grep sh, pass that into. So what this is going to do is cat is going to read in output whatever it is given on standard input. So it's going to read the file etc password, output that directly. The output of that is going into a new process called grep, passed in with the argument sh, which is going to look for everything with an sh, and then put that in this file. So we should be able to cat that, and we can see these are only the contents of the file etc password that contain the letters sh, which is kind of crazy and super cool. And again, this is nothing special, right? So the shell is using the commands as they are, right? This is where you get this really beautiful simplicity in this design. Things are very simple. but we can use them and modify them in complex ways, and the programs themselves don't have to change or do anything special. So the shell here is simply making the standard input of the program to be from the file etc password. So when the program says, hey, give me input, the shell essentially, in a very cool way, gets it to read from this file. Okay, one more cool thing we're going to look at here is programs have a lifetime. They execute for a while and then die. So programs return a number, which is considered their exit code when they finish executing. And this indicates basically whether the program was successful or caused some kind of failure. So by default, and this is kind of annoying, but it's a convention. So 0 indicates success. So when a program returns 0, that means everything went well. You can think of it as like yep, there were 0 errors. And anything not 0 means some kind of failure. And if you succeed, you kind of have only one kind of success, right? Everything went well, like there were no problems. But if you encounter a problem, there may be many different problems. So this is why this number, it could be 1, 2, 3, 5, 10. I mean, literally kind of anything. And those specific values may mean something or it may not. And the cool thing about the shell is it actually will provide a special variable to you that means the last program's exit code. And this is literally $? Is this special variable. So whenever we run, so we can do things like ls space -la/, and then we can do echo $? And this will output the exit code of the previously executed program. So it outputs 0. This is how we know that the ls-la was successful, because its return code, its exit code was 0. What happens if I do echo $? Again? What's that going to output? And more specifically, whose exit code is that going to output? Echoes, exactly. Not of the ls-la. So of course that was successful because it was able to do it, but it's not actually giving us any information. So we can actually try a different one. If we try to ls-la, remember earlier in today when we what happened when we tried to list the contents of a directory that didn't exist, or a file that didn't exist?
Give you an error?
Yeah, it says cannot access /AdamDHacks. And so what do we think is going to happen when I echo out this the exit code of this ls command?
Gonna give you an actual number?
Yeah, what do we know that it's not going to give us? Yeah, not 0. There we go. Thanks. Yeah, not 0, right? It may be 2, it may be 5, it may be 10, it may be -1, it may be 1,000. We don't know. But we know it's not going to be 0. Now, what happens if I do echo again? Yeah, it'll output 0 because it's the previous echo was successful. For those that can tell the colors, my terminal is actually, my shell is actually changing something here. The little prompt went from green to red. Why did it do that here? It saw the error exactly. My whatever stupid thing I'm using for the terminal and to style it and whatever actually looks at every process you execute, right? It's looking at the return code, and it actually is changing information in the prompt to tell you what happened in that last command, which is pretty cool. And this is exactly what it uses. It uses this exit code. Okay, this is an important concept. It'll definitely come up later when we start writing programs. We'll see how to write these. But in addition to this, it actually gives us the really cool ability to do conditionals in the shell. So we can do things like use this and. So this means and. So first execute foo, and if foo was successful, then execute bar. So if foo's exit code is 0, then execute bar. So this is essentially is like an if condition on executing bar. Bar won't always execute. It only executes if foo was successful. Another way that this is used a lot is like in the to pipes. So this is again where it gets confusing, and this is why if you don't like it, details, computer science is probably not for you, and maybe hacking is definitely not for you because these details matter a lot. So the single pipe, a single bar is a pipe. So execute foo, set the output of foo as the input of bar. 2 bars next to each other mean an or. So this means first execute foo. If the exit code is 0, stop, don't do anything. If the exit code's not 0, so if foo fails, then execute bar. So you can do things like the cool thing, and actually the way this is used a lot is kind of as like a poor man's error detection. So you can say ls foo bar and echo does not exist. So I know that, oops, and I just messed up because I only had 1 bar after I just made that whole tirade about attention to detail. But I did double check it before I hit enter. So the double bar is going to say first execute the command on the left. If it fails, then execute the command on the right. And so this tells us, yep, and it says does not exist. Now, if I change the thing to be etc PASSWD, we don't get the does not exist because the first one was successful and it doesn't, nothing happens. Cheeto Bandito, we stream weekly at 5 p.m. Pacific on Wednesdays. Cool. And I can do things. Oh, the other cool thing is, yeah, this is another thing of like, okay, first go into this directory, and then only if that was successful, so only if that existed, then output password. So if I did foo bar, it can't execute, it can't change directory to /foo bar because that doesn't exist. And then it doesn't try to execute ls because it knows that that condition was an error. Cool. All right. So at this point, we're done with the meeting for today. We'll stop here. I think maybe what we'll do next week is and what you can start doing now is start working on the Bandit over the wire war games. So these are some of my favorite ways of getting to get better at using the command line. So let's look at that real quick. Feel free to help each other out about how to get connected because it's a war game. So, this goes over the stuff that we talked about. So please, read the things on here, all this kind of stuff. There's a level 0. They're all different kind of ways of using exactly the things that we talked about. So like this goal for level 0 is just to get logged in. So this is about using the SSH command, how to access a remote machine. So you're going to connect here. And then you want to get level 0 to level 1. It tells you how to get the thing. And the super cool thing is for every single level in Bandit, it shows you, hey, these are the commands you may need to use to solve this level. So you've learned how to learn, right? What you can do is if you're unfamiliar with any of these commands, read the manual, do man file, man do, man find, so that you can understand how to use these. And this knowledge that you're building now, you're going to keep working on this and building up this awesome base of knowledge so you'll be an excellent command line navigator and master. And I think with that, it's 7. So we are donezo.
That is it. Also, everybody, the Bandit challenges, the first 20 is our qualifier to play CTF. So this is it. You're now prepared to take down the 20 and become a CTFer.
It's almost like why I chose that.
Nice.
All right, cool. See you, Twitch people. This was fun and weird.